All right, what's up, guys? This is Jacob Waldrop with the Materials Advantage chapter at Clemson University.
Hi, I'm Katie, and I'm the secretary.
And we want to talk to you today about the 3D printer that we purchased with the help of the Ceramic and Glass Industry Foundation. So this 3D printer is the Lulzbot Mini 3D printer. And right now we are currently trying to play with 3 different materials. We're playing with ABS, PLA, and ceramic. And so with these materials, what we're trying to do is we're trying to determine what the capabilities of 3D printer are, the complexity of the parts that we can do, because all these materials are different. So take the ceramic, for instance. The ceramic, you have to heat it up before it enters the hot end, where it won't extrude right and you won't get kind of what's desired. And then after you extrude it and the part's made, you still have to go off and sinter it and get it fired. With the ABS is a lot cheaper, it's a lot more cost effective. The only problem is it tends to warp, and so parts kind of don't look as good as you want them to. So you definitely have to go a little bit slower with those, maybe go on the lower end of temperatures. And then next semester, we're actually getting some PLA. And so with this PLA, it's supposed to not warp as much, and it's a polymer as well. And we're going to see maybe making keychains or something with that in the future.
This fall, we are participating in MS&T in Portland. And for MS&T, they have the competitions, including the mug drop and the disc toss. With our 3D printer, we're trying to see if we can make the mug and the disc from our ceramic filament and kind of see how it compares to regular slip casting. This is also helpful because it allows us to reproduce the product as many times as we want. If we mess it up, doesn't come out how we want, we can just change it in SolidWorks or whatever program we're using and print it again until we're happy with the product.
All right, so another great thing we're trying to do is we're trying to promote the club, and we're trying to promote MSC as a whole. And so one of the great ways we're doing that is our advisor, Dr. Pong, has made these little piggy banks, if you can see. Has the kind of opens, and he actually gives these to some students as he goes to certain elementary schools. And so that's a great way to get people interested in MSC program as a whole, and then eventually maybe into Material Advantage as well.
Our new 3D printer isn't just helpful to the students, it's also helpful to the professors here at Clemson. There are some professors that are researching additive manufacturing, and by seeing what we're able to do with our 3D printer, it helps their research, and it also gives us a way to connect with our professors.
So one great program that Clemson has is called Makerspace. And Makerspace, they have 3D printers, laser etchers, and laser cutters, a couple other different machines that are kind of too expensive for Clemson students to normally have access to. And so they allow us to have access to this. And each semester they do demonstrations where they bring in kids from lower grades and show them, like from high school, middle school, and elementary school, and show them the 3D printers, what can be printed, what the laser cutters can do. And hopefully we plan to get involved in that, because that would be a great way to promote MSC as a whole, and it would be a great way to promote our club as well. Because they do stuff that aligns with ours, it's a great way to promote what we're doing as well. And then another thing we're going to try to do is we might use the 3D printer and maybe make some keychains and see if we can't do some fundraising with keychains, give people on campus something cool to just have in their hands, and just to think about 3D printing and think about Material Advantage as a whole.
Another way that purchasing this 3D printer is helpful to the students here at Clemson is that 3D printing is becoming really popular in actual engineering firms. It's a cost-efficient way for companies to see if their product will work out or not. If it doesn't, they're able to just change it, whatever they need to change, material, dimensions. It shows where it fails and whatnot. It's just a really helpful way to remake something multiple times without having to spend the money that it would take to make the actual product.
All right, so right now we've just barely begun to scratch the surface of what this 3D printer can do and what all the different materials that we have can do as well. And so we're gonna do a lot next semester with exploring the ceramic filament. There's a lot of questions and a lot of problems that come up with the ceramic filament because it is so brittle and it's a lot newer. You have a lot more knowledge about plastics and you have a lot more knowledge about metals when it comes to additive manufacturing than you do ceramics. So there's more questions that are raised and there's more questions to answer. So we're going to try to answer some of those questions. Also with the help of the MS&T conference, that'll help us because it's ceramic. It'll help us answer some of those questions while trying to do some of the domes and the mugs, the discs and that kind of thing.
Again, we'd just like to give a big thanks to our advisor, Dr. Palm. We'd also like to thank the Ceramic and Glass Industry Foundation for giving us the grant to purchase this 3D printer, and also the Material Science Department for helping us fund things like filament and whatever small expenses we might need.